October 21st, 2025, 3I/Atlas slips behind the Sun right as it hits its most active phase. For 6 weeks, every telescope on Earth goes blind. No images, no spectra, no signal. Scientists can't track it, can't confirm if it's stable or changing course. Is this just cosmic timing or the perfect moment for something to move unseen? December will reveal everything. Let's dive right in. When 3I/Atlas slipped behind the Sun on October 21st, 2025, astronomers called it the cleanest blackout in modern observation. For 6 entire weeks, Earth is blind. No optical image, no radar echo, not even a thermal signature can get through. The sun's glare drowns every wavelength, a wall of light nearly 1 million miles thick. And yet this blackout isn't random. It arrives at the exact moment when 3I/Atlas becomes most active, its closest approach to the sun, when hidden materials erupt, and a comet's true nature is revealed. That timing alone is enough to raise eyebrows, because if anything were to change, a shift in course, a sudden burst of gas, even a maneuver, it would happen right now in total darkness. No telescope could see it. No data would record it. When 3I/Atlas returns to view in December, we'll either confirm what we know about physics or be forced to question it. The blackout isn't a malfunction or a solar conspiracy. It's geometry, a celestial alignment where the sun blocks our line of sight completely. But that doesn't make it less unsettling. Because October 29th, just 8 days after the blackout starts, marks perihelion, the moment 3I/Atlas faces its highest temperature and strongest radiation. That's when a comet usually cracks open, releasing gas, dust, and sometimes fragments. This is when it speaks. But now we can't hear it. To astronomers, that silence isn't just inconvenient. It's dangerous. If the object shifts orbit or behaves differently, the entire event will unfold unobserved. The implications? Tremendous. So before the blackout hit, every major observatory rushed to collect data, to create what scientists call receipts, the last clear snapshots before the unknown. The James Webb Space Telescope was first to act. Under emergency clearance, it captured an infrared spectrum on September 18th that shocked the community. The ratio of carbon dioxide to water wasn't just unusual, it was 8:1. In ordinary comets, water dominates. But here, carbon dioxide overwhelmed everything. It wasn't a typo. The data held up. What Webb revealed was a chemical fingerprint that didn't fit any known model of a natural comet. Inside NASA, leaked chat logs showed a tense debate. Should they publish or wait? Some feared misinterpretation. Others, led by Dr. Melissa Jiang, argued that delaying could mean losing the most critical data point in human comet science. "We'll never get this view again," she wrote. She won, and the numbers went public. Overnight, the world took notice. Then came new evidence from Japan's Kiso Kamagata Observatory. Their spectral maps glowed with nickel but showed barely any iron. No one could explain that. The instruments were rechecked, the calibration repeated. Still, the nickel lines held. The chemistry of 3I/Atlas seemed to operate by a different rule book. And just days before the blackout, Mars joined the hunt. ESA's Trace Gas Orbiter recorded a faint, steady plume of gas directed precisely toward the sun. It wasn't chaotic as comets usually are. It was consistent, like an engine idling. To mission engineers, that meant one thing: controlled outflow. Whether natural or not, it showed purpose. When the Mars Express confirmed it, the data painted a single haunting picture. A large, slow-spinning object, rich in carbon dioxide and nickel, losing mass in one clean, sun-facing direction. Too stable for a random snowball of ice and dust, too deliberate to ignore. So, what is 3I/Atlas doing behind the sun right now? As Earth's view faded, the scientific community split. Mainstream researchers called for caution. Unusual chemistry doesn't mean design, one headline read. Comets, after all, are chaotic. Their surfaces crack, spin, vent, and drift unpredictably. But others weren't convinced. Because this isn't just an odd comet, it's an interstellar visitor, the third ever recorded, after Oumuamua and Borisov. And unlike its predecessors, it isn't cutting across the solar system at random. 3I/Atlas is moving almost perfectly along the solar plane, 5 degrees off the ecliptic, threading between planetary orbits as if following a route. Statistically, that's a 1 in 20,000 chance. Not impossible, but not easy to shrug off. Among those questioning the odds is Dr. Alo, who proposed what she calls the solar Orth scenario. Her theory? 3I/Atlas could be using the sun itself as a slingshot, firing a brief controlled burn during perihelion to alter its trajectory. If true, it would explain the chemical mix, the outflow geometry, and the timing of the blackout. The test, she says, is simple. If it's natural, its orbit in December will match predictions exactly. If it's off by even 10 meters per second, that's not random venting. That's intention. Her hypothesis sent ripples through scientific circles. Some mocked it as reckless. Others quietly admitted the math was solid. And that's why December matters so much. It's a test not of belief, but of measurement. Because the Vera Rubin Observatory will have the final word, its positional accuracy, 10 milliseconds, the width of a coin seen from 1,000 kilometers away, will determine if 3I/Atlas held its course or broke it. Every observatory, every data set, every prediction rests on that single verdict. While scientists argued, the public filled the silence. In early October, 3 massive coronal mass ejections exploded from the sun, lighting up the sky with auroras as far south as Kansas and France. Online, theories went wild. Some claimed the solar flares were linked to the blackout. Others insisted 3I/Atlas triggered them. But professionals pushed back firmly. The blackout, they said, is geometry, not conspiracy. The sun simply outshines everything else. Still, the timing fed the mystery. Amateur astronomers began spotting multiple green comets glowing in the night. One enthusiast, Isabel Ruiz from Madrid, posted a viral thread claiming 17 were visible at once, including 3I/Atlas. Experts corrected her. Only 4 were that bright. But by then, the internet had moved on. Perception had already become reality. Meanwhile, in professional labs, the focus sharpened. ESA and NASA teams fine-tuned prediction models for the object's reemergence, factoring in solar wind changes and coronal interference. Every number, every fraction of an arc second mattered. Because when 3I/Atlas returns to view, even a tiny deviation could upend decades of understanding. The Vera Rubin era has changed everything. Before it, interstellar visitors were once-in-a-generation discoveries. Now, automated sky sweeps may reveal dozens each year, turning miracles into data points. For the first time, humanity can move from anecdote to analysis, from speculation to statistics. And yet, amidst all this progress, one truth lingers. 3I/Atlas is different. Its chemistry defies known patterns. Its motion aligns too precisely with the planetary plane. And it disappears at the one moment when verification becomes impossible. Coincidence, or something else entirely. Whatever the answer, the stakes couldn't be higher. When 3I/Atlas emerges again in December, its path will decide the outcome. If it matches prediction, science wins. If it doesn't, something unprecedented will have just happened behind the sun, unseen but undeniable, because in the end, the cosmos doesn't need to shout to shake us. Sometimes it just waits, in silence. When 3I/Atlas reappears in December, we'll finally know the truth. Did it follow the path physics predicted, or change course in the one moment no one could watch? Whatever happens, this event reminds us that even with all our technology, the universe still holds the power to surprise us and to humble us. Until then, every scientist, every sky watcher, and every one of us is waiting for that first image to return. If you want to be among the first to see what really happens when 3I/Atlas comes back into view, like this video, share your thoughts in the comments, and subscribe to Galactic Breaking News. Turn on notifications so you never miss an update, because the moment of truth is almost here, and Galactic Breaking News will be right there when the sky finally speaks again.